The theoretical foundations and key concepts discussed herein not only deepen our comprehension of fashion trend dynamics, but also illuminate the pathways through which AI and data analytics can refine and revolutionize forecasting methods. This intricate dance between theory and technology heralds a new era for the fashion industry. Fashion, an industry characterized by its constant evolution, faces the challenge of keeping pace with changing consumer preferences and the relentless evolution of trends. In this environment, the quest for innovative trend prediction methodologies has never been more critical. Our journey begins with a quest to integrate artificial intelligence and data analytics into the heart of fashion trend forecasting. This isn't just about staying ahead, it's about reimagining the future of fashion through the lens of technology, seeking competitive advantage and enhancing operational efficiency. The impetus for diving deep into AI-driven trend prediction is fueled by the industry's desire to amplify market responsiveness, optimize supply chain operations, and craft personalized consumer experiences. This initiative stands as a testament to the transformative power of data-driven decision-making in fashion. The groundwork of our investigation is established through an extensive review of existing literature, critically examining key methodologies and resources that underpin data-driven innovation in fashion forecasting. This includes evaluating the predictive power and generalizability of machine learning models with particular attention to performance metrics, feature selection, and overfitting risks. Performance metrics like accuracy, precision, and recall help assess how well a model performs across various forecasting tasks, guiding improvements and benchmarking effectiveness. Feature selection helps choose the most relevant data inputs to improve model accuracy and reduce complexity. It also plays a pivotal role in enhancing model interpretability and computational efficiency by isolating the most relevant predictors from high-dimensional fashion data sets. The review also explores the strategic role of A/B testing as a rigorous experimental framework for validating model-driven decisions in real-world settings, such as consumer-facing platforms or merchandising strategies. Furthermore, it highlights the increasing importance of open-source fashion datasets, which foster transparency, reproducibility, and collaborative advancement in the field. This scholarly synthesis not only contextualizes current technological capabilities, but also outlines a roadmap for leveraging artificial intelligence to navigate and anticipate the fast-paced, ever-evolving nature of the fashion ecosystem. As we stand on the precipice of a new era in fashion trend forecasting, our exploration into AI and data analytics heralds a promising horizon of innovation and efficiency. Join us as we embark on this exciting journey, charting the course for the future of fashion. After setting the stage with our exploration's objectives, let's zoom in on the core concepts that are pivotal to understanding the fusion of artificial intelligence with fashion trend forecasting. At the core of our research are foundational concepts that are reshaping the landscape of fashion trend forecasting through advanced computational methods. To understand where a trend is going, we first need to analyze its historical trajectory. Time series regression is a statistical technique that models the relationship between a dependent variable, such as item sales, social mentions, or search volume, and time as an independent variable. By fitting linear or non-linear models to sequential data, we can quantify trend components, detect seasonality, and even isolate noise or irregular fluctuations. For example, a consistent upward slope in the regression model might suggest a growing interest in wide-leg trousers, whereas cyclical pattern might reveal seasonal preferences like pastels in spring. In practice, we often use autoregressive models or models with lagged variables, which consider previous observations to predict future values. This allows us not just to describe past behavior, but to project future states, making time series regression a cornerstone of data-driven trend forecasting in fashion. Machine learning, a branch of AI that allows computers to learn from data, enables systems to autonomously identify patterns and extract insights from vast heterogeneous fashion datasets, including consumer behavior, social media content, and historical sales data. It improves predictions or decisions without being explicitly programmed for each task, making it especially valuable in adapting to evolving market conditions. Artificial neural networks, inspired by the structure and function of the human brain, are particularly effective in modeling nonlinear relationships and recognizing subtle visual or contextual cues within unstructured data such as images and text. Clustering algorithms, a type of unsupervised learning used to group similar data points, play a pivotal role in organizing complex data sets. In fashion, they can reveal customer segments or group similar styles, such as colors, patterns, or silhouettes, thereby facilitating the detection of emerging trends and market segments. Collectively, these technologies constitute a robust analytical framework for data-driven fashion forecasting in an increasingly dynamic and digitized industry. Machine learning empowers predictive models to autonomously learn from vast datasets, offering unprecedented predictive accuracy. These models forecast future trends based on past data, such as sales figures, weather patterns, or social media activity, allowing businesses to anticipate shifts in consumer demand and market dynamics. Meanwhile, neural networks excel at identifying complex patterns, refining prediction models with a level of precision that was previously unimaginable in the fashion industry. Clustering enables targeted trend analysis and personalized marketing by grouping fashion items and consumer preferences. This intelligence feeds directly into supply chain management, ensuring that production aligns seamlessly with predictive insights, optimizing the entire fashion supply chain. Quantum computing introduces a new horizon for fashion trend prediction with the potential to process data at unprecedented speeds. This emerging technology promises to revolutionize data analysis, making trend forecasting more efficient than ever before. These core concepts not only illuminate the path toward precision and efficiency in fashion trend forecasting, but also highlight the transformative potential of AI and technology in the industry. As we harness these technologies, we unlock new possibilities for creativity, innovation, and sustainability in fashion. Having set the stage for our exploration into the fusion of AI with fashion trend forecasting, let's delve into the meticulous methods that underpin our comprehensive literature review. Our inquiry begins with a structured and strategic methodology aimed at mapping the intersection of artificial intelligence and fashion trend prediction. By developing a comprehensive mind map, we systematically chart the conceptual terrain, identifying key domains, methodologies, and interrelationships. This process is guided by an expansive set of search terms, carefully curated from both the theoretical foundations of fashion forecasting, including trend cycles, consumer behavior, and aesthetic theory, and the technical dimensions of artificial intelligence, such as supervised learning, computer vision, and natural language processing. The resulting knowledge framework not only supports a holistic understanding of the field, but also reveals underexplored opportunities where AI can meaningfully enhance predictive accuracy and decision-making within the fashion industry. Venturing through multiple scientific archives and databases, we adopt a comprehensive and scholarly approach. This iterative process, refined through ongoing discovery, aligns our search with emerging patterns and crucial gaps in the existing body of knowledge. The rigor and validity of our literature review are maintained through the application of clearly defined inclusion and exclusion criteria, designed to ensure methodological precision and thematic relevance. Studies are selected based on their direct engagement with the convergence of artificial intelligence techniques and fashion forecasting practices, including applications in trend analysis, consumer insight generation, and predictive modeling. Simultaneously, sources lacking empirical focus, methodological transparency, or alignment with our research objectives are systematically excluded. This curated selection process ensures a concentrated synthesis of high-quality, contextually pertinent insights, forming a robust foundation for understanding the current state and future potential of AI-driven innovation in the fashion domain. The culmination of our methodological journey is a thematic analysis, where insights are woven into a coherent narrative. This synthesis not only reveals the current state of AI and fashion trend prediction, but also illuminates the path forward, charting unexplored territories in this exciting field. With a solid foundation laid by our literature review methods, we're poised to unlock groundbreaking insights into the role of AI in fashion. The meticulousness of our approach ensures that every finding is built on a robust base of knowledge, promising to enlighten and inspire. Having explored the rigorous methods that scaffold our literature review, we now venture into the theoretical foundations and key concepts that anchor our understanding of fashion trend prediction in the era of artificial intelligence. At the forefront of fashion trend forecasting lies a complex and evolving theoretical landscape that captures the multifaceted nature of style diffusion and cultural influence. One such concept, discrete asymmetry, reflects the inherently nonlinear and often unpredictable fluctuation of trends, characterized by abrupt shifts, cyclical resurgences, and irregular adoption patterns. In parallel, the trickle-down theory, rooted in classical sociological thought, posits that fashion trends originate within elite or haute couture circles and gradually permeate mainstream consumer markets. In contrast, the trickle-up theory, informed by contemporary cultural studies, highlights the rise of grassroots innovation, where subcultural or street-level styles gain traction and ultimately shape the aesthetics of high fashion. Together, these frameworks illuminate the bidirectional and dynamic flow of influence in the fashion ecosystem, offering critical insight into how trends emerge, evolve, and are disseminated across social strata and cultural contexts. Fashion trends are shaped by a myriad of factors. Media channels broadcast and amplify trends, celebrity endorsements drive consumer preferences, and the vibrant energy of street style introduces unique dimensions to fashion. These influences converge to mold the ever-evolving tapestry of the fashion industry. Beyond external influences, personal creativity and social dynamics play pivotal roles in fashion trend formation. The individual's ability to experiment and express through fashion interacts with social platforms, fostering a diverse and inclusive fashion landscape that celebrates creativity and innovation. The theoretical underpinnings of our study extend to the models that predict fashion trends. From the analysis of historical data to the interpretation of current cultural shifts, these models leverage both art and science to forecast the future of fashion with remarkable precision. The theoretical foundations and key concepts discussed herein not only deepen our comprehension of fashion trend dynamics, but also illuminate the pathways through which AI and data analytics can refine and revolutionize forecasting methods. This intricate dance between theory and technology heralds a new era for the fashion industry. In addition to macro-level cultural and economic influences, individual creativity and social interaction serve as critical micro-level drivers in the formation and propagation of fashion trends. The capacity of individuals to engage in self-expression through sartorial choices, often characterized by experimentation with aesthetics, identity, and subcultural affiliation, acts as a catalyst for innovation within the fashion system. These creative impulses are amplified in the digital era through social media platforms and online communities, which function as participatory arenas for style dissemination, peer validation, and collective sense-making. This convergence of personal agency and social connectivity contributes to a more pluralistic and democratized fashion landscape, where diverse voices and emerging subcultures play increasingly influential roles in shaping mainstream fashion narratives. The theoretical underpinnings of our study extend to the models that predict fashion trends. From the analysis of historical data to the interpretation of current cultural shifts, these models leverage both art and science to forecast the future of fashion with remarkable precision. The theoretical foundations and key concepts discussed herein not only deepen our comprehension of fashion trend dynamics, but also illuminate the pathways through which AI and data analytics can refine and revolutionize forecasting methods. This intricate dance between theory and technology heralds a new era for the fashion industry. At the heart of fashion's evolution lies the media's unparalleled influence. From the silver screen to the pages of glossy magazines and the endless scroll of social media, media channels are pivotal in broadcasting new styles and trends to a global audience, crafting the zeitgeist of fashion. Celebrities and influencers wield significant power in shaping fashion trends. Their endorsements and personal style choices often set the wheels of trend adoption in motion, inspiring millions to emulate their looks, thereby accelerating the spread of new trends. The streets serve as a vibrant canvas for self-expression, where everyday fashion enthusiasts create and showcase trends from the ground up. Street style, with its authentic and diverse expressions, plays a crucial role in informing and inspiring the fashion industry. Technological advancements and social dynamics further fuel the fire of trend formation. AI and data analytics mine vast quantities of data from social media and consumer interactions, pinpointing emerging trends and enabling brands to respond with agility and precision. The influences and drivers of fashion trends are as varied as they are dynamic, from the power of media and celebrity influence to the authenticity of street style and the precision of technology. Together, they weave a complex fabric of trends that mirror our society, culture, and times. Having explored the diverse influences shaping fashion trends, let's turn our attention to the technological tools and methods that are revolutionizing the way the fashion industry predicts and responds to these trends. At the cutting edge of fashion forecasting are advanced data-driven methodologies that leverage the power of computational intelligence to anticipate consumer preferences and emerging style directions. Machine learning algorithms, including decision trees, support vector machines, and ensemble methods, are employed to detect intricate patterns and correlations within high-dimensional data sets. Artificial neural networks, particularly deep learning architectures such as convolutional and recurrent neural networks, further enhance predictive capabilities by modeling complex, nonlinear relationships across diverse data sources. These tools process vast volumes of structured and unstructured data, ranging from consumer purchase histories and transaction logs to user-generated content such as online fashion reviews, social media activity, and visual imagery. Through sophisticated feature extraction and pattern recognition, these models generate actionable insights that inform product design, inventory planning, and marketing strategies, ultimately enabling a more responsive and forward-looking approach to trend prediction in the fashion industry. Computer vision and AI play critical roles in identifying and categorizing fashion trends. By analyzing images and videos, these technologies can detect emerging styles and color trends, providing a real-time pulse on what's popular on the streets and online. Clustering algorithms play a vital role in segmenting and interpreting consumer behavior by identifying natural groupings within complex data sets, such as shopping patterns, style preferences, and demographic traits. This segmentation enables fashion brands to tailor their offerings and marketing strategies to distinct audience profiles with greater precision. When combined with predictive analytics, these tools provide a robust framework for anticipating future fashion trends based on historical data, real-time consumer feedback, and market signals. This integrated approach empowers brands to stay relevant, agile, and strategically aligned with evolving customer demands in an increasingly competitive and fast-paced industry. Emerging on the horizon is quantum computing, with the potential to process and analyze data exponentially faster than conventional computers. This technology could soon transform fashion trend analysis, making it possible to predict trends and optimize supply chains with unprecedented speed and accuracy. These technological tools and methods are not just supporting the fashion industry. They are leading it into a new era of innovation and precision. By harnessing the power of AI, machine learning, and potentially quantum computing, fashion brands are not only predicting trends, but also shaping the future of fashion. Having explored the diverse influences shaping fashion trends, let's turn our attention to the technological tools and methods that are revolutionizing the way the fashion industry predicts and responds to these trends. Neural networks, particularly recurrent neural networks, RNNs, and convolutional neural networks, CNNs, are key to analyzing both sequential and visual data in fashion forecasting. RNNs are well suited for detecting temporal patterns in trend evolution, while CNNs excel at extracting features from fashion imagery. Together, they enable more accurate predictions of stylistic and seasonal trends by uncovering insights from large, complex data sets, offering levels of foresight that traditional methods could not achieve. Supervised learning models operate by training on labeled data sets, enabling them to perform highly specific tasks such as classifying images, answering questions based on text, analyzing sentiment, and converting speech into text. These tasks rely on clearly defined input-output pairs, where the model learns to generalize patterns from structured examples. For instance, in image classification, the model learns to associate pixel patterns with categories, while in sentiment analysis, it discerns emotional tone from annotated language samples. On the other hand, unsupervised learning does not depend on labeled data. Instead, it uncovers hidden structures and patterns in vast, unstructured data sets. This makes it particularly powerful for creative and generative applications. Models can imagine entirely new images, synthesize realistic video content, and generate coherent language or even speech without direct supervision. Through language modeling, they grasp the underlying grammar and semantics of text, enabling them to write fiction, simulate conversation, or model linguistic trends. Some capabilities, like image captioning and machine translation, blend both worlds. These tasks benefit from the structure of supervised learning, while also requiring the flexibility and abstraction of unsupervised techniques. Together, these two paradigms, supervised and unsupervised learning, form the backbone of modern artificial intelligence, powering everything from recommendation systems to generative art. Big data plays a crucial role, providing the raw material for predictive analytics in fashion. By aggregating and analyzing data from sales, social media, and more, brands can make data-driven decisions that resonate with current consumer demands and anticipate future needs. The array of techniques and models in fashion trend prediction not only enhances the accuracy of forecasts, but also empowers designers and brands to innovate responsibly. As we harness these advanced tools, the fashion industry becomes more dynamic, precise, and anticipative than ever before. While the tools and techniques we've discussed bring incredible precision to fashion forecasting, they also come with their own set of challenges and limitations. Let's delve into these complexities to understand what truly goes into predicting the future of fashion. A core challenge in the domain of fashion trend prediction lies in the well-established principle of garbage in, garbage out, GIGO, underscoring the critical dependence of predictive accuracy on the quality, completeness, and representativeness of input data. Predictive models, regardless of their algorithmic sophistication, are inherently constrained by the limitations of the data sets they are trained on. Incomplete, outdated, or biased data, whether stemming from underrepresented consumer segments, skewed sampling methods, or noisy user-generated content, can compromise model performance, leading to erroneous trend forecasts. Such inaccuracies not only diminish the utility of these tools for designers and merchandisers, but also risk reinforcing fashion stereotypes or overlooking emerging cultural expressions. As a result, robust data pre-processing, bias mitigation strategies, and ongoing data validation are essential components in developing reliable AI-driven forecasting systems within the fashion industry. Another critical challenge in fashion trend prediction involves addressing inherent biases embedded within historical data sets. These biases, often reflective of past industry norms, dominant market segments, or narrow cultural narratives, can skew model outputs by reinforcing outdated aesthetics and marginalizing emerging or underrepresented trends. If left uncorrected, such biases risk perpetuating systemic exclusions and reducing the responsiveness of predictive models to evolving consumer behaviors and cultural shifts. To counteract this, it is essential to curate datasets that are both diverse and inclusive, encompassing a broad spectrum of demographics, body types, geographic regions, subcultural influences, and fashion expressions. Incorporating data equity frameworks and fairness-aware algorithms further enhances the ability of AI systems to produce trend forecasts that are not only accurate, but also socially attuned, thereby fostering innovation and inclusivity in the fashion ecosystem. The inherently fast-paced nature of fashion poses a unique challenge. Trends can emerge and fade within a short period, making it difficult for even the most sophisticated models to keep pace without real-time data and continuous learning capabilities. Ethical considerations and privacy concerns are also at the forefront of fashion trend prediction. The use of personal data, such as shopping habits and social media activity, must be balanced with respect for consumer privacy, requiring stringent safeguards and transparent data practices. The road to accurate and effective fashion trend forecasting is fraught with challenges that require not only technological innovation, but also ethical diligence and a commitment to quality. As we navigate these complexities, the fashion industry continues to evolve, driven by a blend of art, science, and responsibility. Navigating the challenges of fashion trend prediction not only requires technical savvy and ethical foresight, but also a keen understanding of its economic and business implications. Let's examine how these predictions influence the financial landscape of the fashion industry. Accurate trend prediction can significantly enhance a brand's profitability. By aligning product offerings with consumer demand, brands minimize overproduction and markdowns, optimizing profit margins. Conversely, misjudging trends can lead to unsold stock and reduced profits, underscoring the high stakes of accurate forecasting. Efficient inventory management hinges on effective trend forecasting. By anticipating what consumers will want next, brands can streamline their supply chains, reduce waste, and respond more swiftly to market changes. This not only cuts costs, but also enhances the agility of businesses in the fast-paced fashion sector. Strategic decision-making in fashion also leverages trend prediction. Data-driven insights inform not just product development, but also marketing strategies and brand positioning, helping companies stay competitive in a saturated market. Brands that can predict and react to trends effectively often enjoy a significant strategic advantage. Moreover, the push towards sustainability in fashion is closely tied to trend prediction. Accurate forecasts help brands produce more responsibly, reducing environmental impact and promoting ethical practices. This alignment with consumer values not only benefits the planet, but also builds stronger customer loyalty. The economic and business implications of fashion trend prediction are profound, impacting everything from individual brands to global market dynamics. As the industry continues to evolve, the integration of sophisticated forecasting tools will be crucial for economic resilience and sustainable growth. The future of fashion trend prediction is increasingly intertwined with artificial intelligence. As AI becomes more sophisticated, its ability to analyze and predict trends from vast amounts of data will become more precise. Expect AI-driven models to offer even more tailored, real-time trend forecasts, enabling brands to anticipate and react to consumer preferences with unprecedented speed and accuracy. Personalization is set to dominate future fashion trends. With advanced data analytics, brands will not only forecast broad market trends, but also cater to individual customer preferences, creating highly personalized shopping experiences. Moreover, the ability to quickly identify and capitalize on micro-trends will allow brands to appeal to diverse consumer groups, enhancing engagement and satisfaction. Sustainability will continue to be a major focus. Predictive models will increasingly incorporate ethical considerations, helping brands minimize waste and reduce environmental impact by forecasting more sustainable trends. This will include predicting the popularity of eco-friendly materials and sustainable production practices. The integration of virtual and augmented reality into fashion trend prediction is on the horizon. These technologies will revolutionize the way consumers interact with fashion, offering virtual try-ons and immersive fashion shows that provide a deeper, more engaging shopping experience from the comfort of home. As we conclude our journey through the intricate world of fashion trend prediction, let's recap the pivotal insights and envision the path forward for this dynamic industry. Throughout our exploration, we've seen how artificial intelligence, data analytics, and a deep understanding of both cultural and technological influences are reshaping fashion forecasting. From AI-driven analytics that enhance precision to the embrace of sustainability, these advancements are setting new standards for how the industry anticipates and reacts to trends. The implications of these innovations are profound. For designers, retailers, and brands, the ability to predict trends with greater accuracy means more efficient supply chains, reduced waste, and more engaged consumers. As the industry continues to evolve, embracing these technologies will be crucial for staying competitive and responsive. However, as we've acknowledged, these advancements come with their own set of challenges. Issues such as data privacy, the rapid pace of change, and the need for inclusivity must be continuously addressed to ensure that fashion trend prediction not only advances in capability, but also upholds ethical standards. As we look to the future, the fashion industry stands on the brink of a revolution. It is up to all stakeholders, design, technology, and business, to collaborate and navigate these changes responsibly. We invite you to join this ongoing dialogue in the comments as we continue to uncover new trends, tackle emerging challenges, and discover opportunities that will define the next era of fashion. Thank you for joining us on this insightful exploration into the world of fashion trend prediction. As the landscape continues to transform, stay connected and informed with us. Together, let's shape a future where fashion not only anticipates trends, but also inspires change.